My name is Chris Johnson. I work for Neil Goodmanstead at North Dakota State University on Zebra Chip and potato. I've worked for Dr. Goodmanstead for about 2.5 years now. And what we're working on are biotyping or haplotyping the different forms of Liberibacter that the psyllids transmit. There's two primary types of Liberibacter. We refer to them as haplotype A or haplotype B. The genome for haplotype B has been published. That was put out in 2011. That was Dr. Lynn's paper, and that's been all done. And what we were consistently seeing in the field and in samples that were submitted to us, there looked like there was a difference between the haplotype A Liberibacter infections and the haplotype B Liberibacter infections. And so what we really wanted to do was get a feel for what was causing that, and if we could track that difference, maybe look at the two different haplotypes of bacteria to see what was different about the bacteria that would cause those types of symptom changes. And so we've been looking at developing colonies and whatnot. This year my presentation will be on the haplotype A genome. So what we did was we collected a new field colony from the lower Rio Grande. Dr. Henny collected that for us. And we grew it in colony, and we are sequencing the genome of the haplotype A bacteria out for comparison to the haplotype B. And what we're going to do now is in different plants and different insect. Of course, the psyllid has biotypes also. We are going to do some side-by-side comparison studies, but that'll probably occur over the winter and into the next spring. And then we can, after we actually see that the differences in the field, we want to try a couple different potato varieties, maybe some tomato, maybe some pepper, to see what the differences between the two haplotypes are. Then we can go back to the genomes, since we have them both now, and try to determine what are where is the pathogenicity coming from, assuming we see field level pathogenicity changes.